All right, so this is question 59. Determine the energy of 1 mole of photons for each type of light. So I'm just going to come over here to my work. The first thing that I wanted to do was take the wavelength in nanometers and switch it using the conversion factor to meters here, giving me 1.500 times 10 to the power of -6 meters. That's my wavelength for this formula, E equals hc over lambda, and this is the formula you use for a lot of the questions that you had in this section. You need to know this constant h, 6.626 times 10 to the power of -34 joule seconds, and then c, the speed of light, 3.00 times 10 to the power of 8 meters per second. Based on what you told me before, you need to know those values, and you need to know the formula. I just popped these numbers into this formula, so h times c divided by lambda, and here's my answer for how many joules per photon. So this formula tells me how much energy for a photon. Down here, I had to consider how many photons there are in 1 mole. So there's 6.022 times 10 to the power of 23 photons per mole. That's another constant that I would assume you need to know. Taking this value and multiplying it by this one gives me 79.8 kilojoules per mole. For B and for C, we're doing basically the same thing. The only thing we're swapping out in B is the wavelength value. So up here, where lambda is, I would take 500 nanometers, convert it to meters, so there's 10 to the power of 9 nanometers per meter, so essentially you're dividing it by 10 to the power of 9, and put it in this same formula. And for C, you're doing the same thing, so same steps we did up here, finding the energy of a photon, and then multiplying that by how many photons there are in a mole, but using this value for wavelength.